Hello, good morning. We'll be discussing numerical analysis in this video. We're talking about some of the iteration that we know: Jacobian, Newton, Gauss iteration, and so on and so forth. So this is the first problem with us. We're talking about Jacobi iteration in this problem. Now, the first thing you need to know about Jacobi iteration is that it must be diagonally dominant. When it is diagonally dominant, then we are sure that the question will converge. Look at this now. This is 5. The magnitude 5 is greater than the sum of these two, which is 1 plus 1, which is 2. Then the diagonal of this is dominant. The diagonal of this is 6 and is greater than the sum of this, which is 1 plus 1, which is 2. We are taking the magnitude. Then the diagonal of this is 10. So this is the diagonal element. And it has to be what? Diagonally dominant. 10 is greater than 2 plus 1, which is 3. Then we are sure that this question will converge. Now, when it is not diagonally dominant, it may converge or it may not converge. But the first thing we have to be sure of is that it is diagonally dominant. And in this case, it is diagonally dominant. There are some questions that you have to re-edit the equation in such a way that if this was its name, this equation now swap for this, then we have to rearrange it. We swap it back, not the numbers, the rows. We swap a whole row like -1, 6 and 1, then 2, 1 and 10. We swap it that way. Now, the first thing to, when you see that it is diagonally dominant as this one is, write your equation. What's your equation? That's your 5x1 plus x2 plus x2 plus x3 to be equals to 8. You write this equation to minus x2 plus 6x1 plus x3 is equals to 12. Sorry, there's a mistake there. This is minus x1 plus 6x2. Now we write this equation to 2x1 plus x2 plus 10x3. That's the equation to be equals to 14. So we've written all the equations. Then after writing this equation like this, you are going to write your x, which you are going to be using for your iteration. How do you know which one to write your x for? The diagonal. This is the diagonal. You make this one x1 subject to the formula here. You make s2 subject to the formula in the diagonal here, and you make s3 subject to the formula in this one. So let's make the diagonal subject to the formula. For this place, we are going to use x1, which is the diagonal. This is the diagonal here, so that's why we're using this one, x1. So if you make x1 subject to the formula, you're going to have x1 to be equals to 8 minus x3 minus x2 to be divided by 5. So this is our x1. This is what we're going to be using for our iteration, equation 1, our x1. For our x2, it is going to be 12 minus x3 minus 6x2 divided by, our x2 will be 12 minus x3 then plus x1 divided by 6. So this is our x2 equation 2. This is what we're going to use for our s2 for our iteration there. Then our s3, you make s3 also subject to the formula. S3 will be equals to 14 minus 2x1 minus x2 divided by 10. So this is our s3. These are our 3 equations that we'll be using. Our x1 from equation 1, our x2 from equation 2, our s3 from equation 3. So now, for your Jacobi iteration, you should be given an initial value. And this is the initial value, the initial guess, which is 0, 0, 0, then transpose, meaning that x1, x2, x3 is equals to 0, 0, 0. That's the function of that transpose there. You have to transpose the matrix. So that means our x1 initially is 0, our x2 initially is 0, and our x3 initially is 0. So with that, all these values, we can get our first iteration by putting 0 in this equation 1, equation 2, and equation 3. So these are our initial guess, as I said earlier. Now, there's another method called Gauss Seidel. Gauss Seidel is almost the same method as the Jacobi iteration, but the only difference is when you are inserting your x1, x2, x3. When we get to that aspect, we'll discuss about it. So let's talk about our first iteration. We already know our equation. So let's talk about our first iteration. Your x1, let me rub off this. Okay, let's use this place for our iteration. Our x1. For our x1 now, we are going to have 8 minus x3 minus x2. That will be 8 minus x3 is 0 minus 0 minus x2 is 0 minus 0, then divided by 5. If you do that, that will be 8 divided by 5. 8 divided by 5, that's 1.6. So this is our new x1 guess. This is the first iteration. The first iteration. We'll do the same thing to get our x2. Our x2 is equals to 12 minus x3 plus x1. That will be 12 minus x3. What's x3? x3 is 0 plus x1. What's x1? x1 is 0 divided by 6. If you divide that, that will be 12 divided by 6, which is 2. This is our first guess for x2. Now for our x3, we are going to have, what's this? 14 minus 2x1 minus 2 times 0, which is 0, minus x2, which is also 0, divided by 10. And that is 1.4. So this is now our initial guess. 1.6, 2, and then 1.4. So this is now our new guesses for x1, x2, and x3. This is what we're going to use in the second iteration. So we're going to use 1.6, 1.4, and then 1.6, 2, and then 1.4. So these are our new iteration that we use. Let's rub it off. So now our x1 now is 1.6 instead of 0. Our x2 is 2, and our x3 is 1.4. These are our new guess. So we still do the same thing. Go for the second iteration. On the second iteration now, it will be x1 to be equals to 8 minus x3. What's x3 now? It is 1.4 minus 1.4. Then minus x2. What's x2? 2 divided by 5. If you calculate that, you are going to get 0.92, which is now our new x1. We do the same thing for x2. x2 equals to 12 minus x3. What's x3? 1.4 plus x1. What's x1? 1.6 divided by 6. If you calculate that also, you're going to get 2.033. The same thing, you get your S3. Your x3 is what? 14 minus 2 times x1, that's minus 2 times 0, which is 3.2. 2 times 1.6 is 3.2 minus x2. What's our x2? 2 minus 2 divided by 10. Notice that we are taking the initial value of this. We are not taking the new value of this, which we should be doing in Gauss Seidel. So we are going back to our reference value. These are our reference value. This is where we are going back to get all our x1, x2, and x3 for. So we calculate this. We're going to get 0.88. So that's our 0.88. That's the new value. Now the question asks us to calculate error 2. There's something called error 1. When you're talking about error 1, you're talking about x1. You'll be looking at the error of x1. When you're talking about error 2, like this one, we're talking about the value of x2. When you're talking about error 3, you go and calculate the value with x3 value. So that's the difference. That's what is error 2. As soon as error 3, I'll use the value of x3 to calculate the error 3. But since it's error 2, I'll use the value of s2. So let's calculate the error. Now, your error, generally in mathematics, error is the magnitude of your new value, s new, minus the old value, s old. That's the meaning of error in mathematics. It's as if you went to the market to buy maybe turkey, and turkey is 3.2. That's the value, the price, and you paid 3,003. Then there's an error. What's your error? The amount you paid minus the original value. That's 100. Even though you paid 3.1, it's still 100. It's still 100 error because there's no negative in error. The error made is still 100. That will be 3.1 minus 3.2. That's why we have magnitude. But if that's to find the percentage, error in percentage is divided by x new times 100. So if it's in percentage, but in this case, we're not looking at the percentage. So since we're not looking at the percentage, let's go to our formula again. Now, this error 2 that we're looking at, that means we're talking about s2 and s2. So what's the s2 new? Our s2 new is this 2.033 minus our s2 old. This is the old value of s2, not the 0 that we got. That was previous value. That was 2 value away. This is the old value that we are using, 2 minus 2. So we subtract this, I'm going to have 0.033 as our error. So that's the error 2. But if the question requires error 3, you'll have used 0.88 minus 1.4. If the value I've asked for error 1, you have used 0.92 minus this. So that's the meaning of these two that we have here. So let's move on. Let's go to, because I see this is a second iteration and this is our new value. This is our new value that we'll use for our third iteration. We are going to 5 iteration now. Let's go. So what's our value? Our x1 is 0.92 that we got previously. We can rewind the video. 0.92, and we got 2.033, and we got for s3 0.88. So let's go to third iteration, the third one. So for the third one, we still do the same thing. We'll apply our formula as when we applying before for the third iteration too. So we are going to have x1 now to be equals to 8 minus x3. That's 8 minus s3, which is 0.88. Then minus x2. What's x2? 2.033 divided by 5. If you calculate that, you are going to get 1.07. So we do the same thing for S2. S2 will be equals to 12 minus x3. What's our x3 now? 0.88. Plus x1. What's our x1? 0.92. Divided by 6. If you calculate this, you are going to get 2.006. 2.006. Same way, we get our x3. Our x3 is 14 minus 2 times x1. x1 is 0.92 minus x2. What's our x2? Our x2 is 2.003. 033 divided by 10. If you calculate this for x3, you should get 1.013. So this is our value after x3. This is our new x1, our new x2, our new s3. If you ask to calculate the error, do the same thing. Error of anyone. If it's error of this, that's this minus this. Because we are not asked to calculate, that's why I decided to ignore the error for each case. So let's move to fourth iteration. Fourth iteration. Let me end this up. Fourth iteration. What's our new value now? We have x1 to be 1.017. That's what we got earlier. Our s2 to be equal to 2.006 and our x3 to be equal to 1.013. So this is all our value. Same way again, I'm going to calculate all our value again. x1 now will be equals to 8 minus x3, which is 1.013, minus x2, which is 2.006, divided by 5. These are fourth iteration, fourth iteration. So we know as we're moving. So that will be 0. To calculate this, gets 0.9962. 0.9962. We do the same thing for our x2. Our x2 is equals to what? 12 minus x3, which is 1.013, plus x1. What's our x1? 1.017 divided by 6. If you calculate this, you should get 2.0006. It's getting smaller, converging. Do the same to our s3. Our s3 is 14 minus 2x1. That's 2 into x1. What's our x1? 1.07. 1.017. Then minus x2. What's our x2? Our x2 is 2.006. 2.006. Then divided by 10. If you calculate this also, you should get 0.996. 0.996. So you see the values are converted. This is trying to convert to 1. This is trying to convert to 2. This is trying to convert to 1. And that's the actual solution. That's where it is converging to. So let's move. Since we asked to go for the fifth iteration. So let's go to the fifth iteration. This is now our new value. Let's move on. The same procedure all through. The same procedure all through. So what's our new x1 now? Our new x1 is 0.996, 0.9962, and our new x2 is 2.0006, and our new x3 is 0.996. So we solve this for our fifth iteration now. The fifth one that we are going to, the fifth iteration, we are going to get x1 to be equals to 8 minus x3, which is 0.996, minus x2, which is 2.0006, divided by 5. If you calculate this, you're going to get 1.00068. Do the same thing for x2. You're going to have the x2 is 12 minus x3, which is 0.996, plus x1, which is 0.996 to 0.9962, divided by 6. If you calculate this, you should have 2.0003. 0003, trying to convert to 2. So also x3 is 14 minus 2x1. What's our x1? That's 0.0096 to 0.9962. Then minus x2. What's our x2? 2.006, 2.0006, then divided by 10. If you calculate this, our x3 should be equals to 1.007, 1.0007. So now the question asks us that what's the value of x1 after the fifth iteration? So we got our x1 to be equals to this after fifth iteration. So our x1 after the fifth iteration is 2.00063. So that's the value of our x1 after the fifth iteration. So we'll continue like that to the 10th iteration. We'll move on to our 6th iteration to get the value of x. Move on to the 7th iteration also, to the 8th iteration, to the 9th iteration. We get to the 10th iteration. So I don't know, maybe I should continue, or you can continue like that and get your x10. It's the same procedure, the way we got our x5. So you continue in that way so that the video will not be too long, and you get to x3 after the 10th iteration. So let's move on. Let's rub off everything on the board. So this is problem 2. The same question, no, the same analysis but different iteration, because this is using Gauss Seidel iteration. And I told you Gauss Seidel iteration and Jacobi, they are almost the same thing. So let's look for our dominant diagonal. Is it dominant? Let's say 4 is greater than 1 plus 2, correct? 6 is greater than 1 plus 1, correct? 8 is greater than 2 plus 1, correct? So that means it is diagonally dominant. So the next thing is to write our equation, which is 4x1 plus x2 plus x3 to be equals to 10. Also, minus x1 plus 6x2 plus x3 to be equals to 5. Also, 2x1 plus x2 plus 8x3 to be equals to 13. Then let's write our diagonal equation. X1, we write x1 for this, x2 for this, and x3 for this. So for our x1, we are going to have 10 minus x2 minus x3 divided by 4. We write the same thing for x2, which is 5. Okay, sorry, 5 plus x1 minus x3 divided by 6. We write the same thing for this, x3 to be equals to 13 minus 2x1 minus x2 divided by 8. So this is all our equations that we use for the iteration, and we are given initial value. What is the initial value? Your x1, x2, and x3, they are all 0, 0, and 0 at the beginning of the iteration. So we have all our initial value. Now there's difference between Gauss Seidel and Jacobi, and this is where it's going to happen. You see, this 0, 0, 0 our initial value, but anytime you get x1 again, you not use this value again immediately in the next iteration. Let's solve it and let's see what I'm talking about. Now let's talk about our first iteration. The first iteration, what will be our x1? Our x1 will be equals to 10 minus 0 divided by 4. So that's 2.5. What will be our x2? Our x2 is now 5. 5 plus x1. Note, assuming it is Jacobi, our x1 is still 0. We'll go back to this. That's different. But now, this is our new x1. Is the new x1. We won't use 0 again. And that's the difference between Jacobi and Gauss Seidel. So instead of using a 0 here, it will be plus 2.5. Then minus x3. x3 have not have a new value, still 0. We still go back to the 0 because we don't have new value for x3. Divided by 6. So that's the difference. So we do this, you get 1.25. You do the same for your x3. To get your x3 now, it is what? 13 minus, it's meant to be 0, but no, that's for Jacobi. Our x1 is now 2.5. That will be 2 times 2.5. 2 into 2.5 is not 0. We use the new value we got now. Minus x2. x2 is not 0 again. That's the new value. 1.25 minus 1.25 divided by 8. If you calculate that, you're going to have 0.8438. And that's the difference between Jacobi iteration and Gauss Seidel iteration. So now this is now our new value after the first iteration. This is our new value that will take to the second iteration. So let's move on. So after the first iteration, we got our x1 to be 2.5, our x2 to be equals to 1.25, and our x3 to be equals to 0.8438. 0.8438. Now, let's go to our second iteration. We have to calculate error after the second iteration. So we calculate the error, and it is error 3. So what I was explaining earlier. So now we have second iteration now. Our x1, we still use our formula, which is 10 minus x2. What's our x2? x2 is 1.25 minus x3. What's our x3? 0.8438 divided by 4. If we calculate this, our x1 will be equals to 1.9766. 1.9766. So let's go for x2 also. Our x2 is equals to what's our x2? 5 plus x1. x1 is no more 2.5. x1 is now this 1.9766. Assuming it's Jacobi, we'll still use this 1.9766. Then again minus x3. x3 is 0.8438 divided by 6. If you calculate this, you're going to have 5 plus that divided by that. So you're going to have 1.0221. Then x3, same procedure. What's our x3? Our x3 will be 13 minus 2x1. x1 is now this 1.9766 minus x2. x2 is now this. x2 is now 1.25. Is the new value 1.0221 divided by 8. If you calculate that, you get your x3 to be equals to 1.0031. Then we have to calculate the error 3 after the second iteration. So this is the second iteration. Our error 3 now will be equals to the magnitude of x3 new, because it's talking about error 3, x3 new minus x3 old. So what's our x3 new? This is x3 new 1.0031 minus x3 old 0.8438. If you take the magnitude of that, you're going to have 0.1593. So this is our error 3 after the second iteration. So we have to find x1 after the third iteration. I'll do that, but I'll not do this. It's still the same procedure. You have to do it 7 more times to get to S10. So let's go to the third iteration, which is for this. I don't want the video to be long. So what's our new x1 after the second iteration? Our new x1 is 1.9766. That's what we got. Then 1.0221 and 1. Oh, this is what we got. 1.0031. This is what we got in the last iteration. So let's now do our third iteration. So our x1 also will still be the same formula, which is 10 minus x2. What's our x2? 1.0221 minus x3. What's our x3? 1.0031 divided by 4. If you calculate this, your x1 should be 1.9937. our x2 is 5 plus x1, which is 1.9937 minus s3, which is 1.0031 divided by 6, which is equals to 0.9984. You can confirm all this calculation, and s3 will be equals to 13 minus 2x1, and our x1 is this, the new one, 1.9937 minus x2, which is this, 0.9984 divided by 8. So we calculate this, s3 is equals to 1.0018. So they say calculate x1 after the third iteration. So our x1 after third iteration is x1 is equals to 1.9937 after the third iteration. So you continue like that for the fourth, for the fifth, for the sixth, seventh, eighth, ninth, till you get to the 10th iteration and you calculate your s3. So that's a long journey. So you continue before you get your answer. So let's move to the next question. It's the same procedure. That's why I'm not going through that same step. The same thing I'm going to be doing all over again. So let's move on. This is cubic polynomial. We are given f of x to be equals to this. We are asked to determine all three roots. A cubic equation must have three roots. All three roots using Raphson method. And our initial guess is 7. Find the first root. Use the initial guess of 7 to find the first root. We are told to apply Raphson method, and we are given initial guess 7 to find the first root. When you are using Raphson method, for you to get any root, they must give you the initial guess for that root. So for this first question, we have f of x to be equals to x3 minus 8x squared. That's our f of x minus 12x plus 144. We need to differentiate this, which is our f prime of x. I know you know differentiation very well. F prime of x, which will be equals to what? 3x squared. That's our differentiation f prime minus 16x minus 12. So that's the differentiation. And we know the Newton-Raphson formula. It says that xn plus 1, the next value plus 1 is equals to the previous value minus the function of the previous value divided by the derivative function of the previous value. So that's our function. And we're given the initial value x naught, x is 0, to be equals to 7. So we have to find the other roots. So to find the other roots, we are not told to use any error. So we just look at when the error is very low, maybe 0.01. So we stop there. Any place the error is low, we assume that is our answer. So let's look at the first iteration. First iteration. We are not asked to find the error, but we are going to just notice the error when the error is low. The first iteration, to find the first root. So first iteration. So now, when n is 0, that means this will be x1 to be equals to x naught, because when n is 0, n will be equals to 0. So that means this will be 0 plus 1, x1, then x naught minus f of x naught, n is 0, divided by f prime of x naught. What's our x naught? Our x naught is 7. that's 7, our x naught is 7, minus f of 7, because s naught is 7. So, and what's f of 7? We'll go back to our function. F of 7 will be 7 raised to power 3 minus 8.7 square. You should understand the way I'm writing it. That's 8 times 7 square minus 12.7. It's not 0.7, 12 times 7, then plus 144. I'm only trying to write it more smart. Some textbook write like this. This dot means 8 times 7 squared, that's 8 times 49, 12 times 7, then divided by f, the derivative of x naught, which is 7, that's 3 times 7 squared, that's 3.7 squared minus 16.7, then minus 12. If you calculate that using your calculator, you have your x1 to be equals to 7 minus 11 over 23, which is 6.1739. Now this is now our new value. Now if you look at between 7 and this, the error is high, because if you do the new value, this 6.521739, if you subtract it from your previous value, we're getting 0.4782, which is very high. The error is too high. We can't take this as an answer. They are too far from each other. This is 7, this is 6.5, too far. As mean this is 7 and this is 6.9992. They are very close. We can say, oh, the error is low, so that means this is our answer. So our new value, our x1 now, is this after the iteration. So let's continue. The error is high, so we'll continue. So let's go to the second iteration. Second iteration, our n2, our n is 1. Our n was 0 previously, so this will be x2 to be equals to x1, because this is 1 now, minus f of x1 divided by f prime of x1. We got our x1 earlier. Our x1 was 6.52 something, 6.521739 minus f of x1, which is 6.521739 divided by f prime of x1, which is also 6.521739. So if we do that, that will be 6.521739 minus, if we press this 6.52, we put it inside this function, you're going to get 2.8. I hope you understand what I'm saying. X is now 6.521739, so that will be 6.521739 raised to power 3 minus 8 times 6.521739 raised to power 2 minus 12 times 6.521739 plus that, you get 2.864139 divided by, you do the same thing for this, you get, if you put this 6.521739 into this equation, you're going to get 11.25. It's not 11 times, so this is actually point. 11.251414. So if we calculate this, your x2 now will be equals to 6.521739 minus 0.25, 0.25, 4558. So that means your x2, now we subtract that, your s2 will be equals to this minus this, it will be equals to 6.228, 6.26, 7181. So this is our new s2. So if you compare it with your x1, what's your x1? 6.52. If you subtract this from this, if you subtract this from this, you are going to have an error that is still large. So we have to continue because the error is like 0.3. That error is too low. We want something like 0.00 something. So the error is still high. We have to move to the third iteration. So let's move to the third iteration. For our third iteration, n is equals to 3. N equals to 2. Sorry, n is 2. So this will be x3 minus n is 2, x2 minus f of x2 divided by f prime of x2. If you calculate that, what's our x2? Our x2 was 6.2. 6.26781 minus f of 6.26781 divided by f prime of 6.26781. So if we subtract these two, if we take this, put this inside this function, 6.26 inside this function and this inside this function, you're going to get 6.267181 minus, when you put that, you're going to have 0.73, 0.732930 divided by 5.55777. If you calculate that, you're going to have 6.267181 minus 0.131875. So we subtract this, your x3 that we just got will be equals to 6.135306. So this is our x3. And if you compare it with this, the error is like 0.131875. This will be the error. It's still high, but it's getting lower. We are getting to 0.1. So let's go to the next iteration. In this case, our n will be equals to a. So that we are looking for x3 plus 1, which is x4, to be equals to x3 minus f of x3 divided by f prime of x3. So we have this x3 minus f of x3 divided by f prime of x3. So what's our x3? Our x3 was 6.135306. So that will be 6.135306. That's our x3 minus f of that value, 6.135306 divided by f prime of 6.135306. So we do this, you're going to have your x4 That's 6.135306. Take this function inside this, whereby the x now is 6.135306. So we are going to put it inside this function. You're going to have, and you divide it with, you're going to have 0.067204. When you divide this, you put this inside this function. You put this inside this function, you divide it, you have this. So if you subtract that, your x will be 6.068102. It's converging a little bit. Now the error, if you subtract from the previous error, you're going to get 0.067204. So it's converging. So we're going to 0.0. I want to have something like 0.001, something like this. So we're not getting there yet. So this is now our new x4. So we'll go for the fifth iteration. Now, the next iteration, our n in that case should be 4. So we're looking for the fifth iteration. So that s5 be equals to x4, what we got earlier, minus f of x4 divided by f prime of x4. If we take that, you're going to have, what's our x4? That's 6.068102 minus f of that x4, which is 6.068102 divided by f prime of 6.06812. So we calculate this, you're going to get your x5. If you calculate it normally, you get your x5 to be equal to 6.0688102 minus, if you take this inside a function, you know how to press the calculator. You just put them inside this function, then divide it by this one. You're going to have 0.030333936. So we calculate that your x5, your x5 will be equals to 6.03466. So the error is getting lower again. The error is now 0. You calculate the error, you get 0.03393. Before it was 0.06. So the error is getting lower. We'll move to the next iteration. So let's go to the sixth iteration, whereby our n will be equals to 5. When our n is 5, we put our x6 to be equals to x5 minus f of x5 divided by f prime of x5. This is equals to, what's our x5? We got x5 to be equal to 6.03. What we got earlier, 4166 minus f of 6.034166 divided by f prime of 6.034166. If we calculate this, you're going to have 6.034166 minus, we press this calculator and you calculate, you're going to have 0.017054. Just be careful about pressing calculator. Just put, you can press this inside calculator and write equals to give you answer. So now write answer is by 3, minus 8 answer square minus 12 times answer plus 144. So you solve that. Immediately divided by 3 answer square minus 16. Don't press equals to all through. The first thing I'm going to do is press 6.034166 in your calculator and press equals to. It will store it as answer. So now you now look for where in your calculator there is answer. You now press answer raised to power 3 minus 8 times answer square minus 12 times answer plus 144. But make sure you put them in bracket like that. Then divided by another bracket. 3. Don't press equals to before. Don't press equals to at all again. 3 answer square times answer square minus 16 times answer minus 12. Close the brackets again. Then press equals to give you this answer here. So that means your x's. That's how I solve it. Instead of doing it one after the other. Your x is, instead of writing this 6.0, is a long number. So use that method. So your x is now will be equals to 6.017112. So now if you check for the error, you're going to get 0.017054, which is getting lower. So let's move to the 7th iteration. Seventh iteration, when our n is 6, x7 equals to x6 minus f of x6 divided by f prime of x6. If you calculate that, you're going to have, what's our x6? Our x6 is 6.017112 minus f of 6.0017112 divided by f prime of 6.017112. So we calculate this. You're going to have 6.0171112 minus 0.008549. How did I get that? 0.00. If you put this in calculator, function of this divided by function of this, you get this. So if you subtract that, our x7 now equals to 6.0085363. So the error is now, if you subtract it, is 0.0085. It's getting lower. We want 0.001 minimum, 0.001. So let's move on to the 8th iteration. When n is 7, we're going to have x8 is equals to x7 minus f of x7 divided by f prime of x7. What's our x7? Our x7 was 6.008. Our x7 is 563. So minus f of 6.008563 divided by f prime of 6.008563. So we press in calculator, your s is equals to 6.008 563 minus 0.00428. So we subtract this, your x8. I got this by putting this function inside there. The x8 will be 6.004283. Your error is now 0.004283, still not up to 0.0001. 0.001. So let's move to the ninth iteration to see what we are going to have. X9 is equals to x8 minus f of x8 divided by f prime of x8. What's our x8? Our x8 is 6.004283 minus f of 6.004283 divided by f prime of 6.004283. So we do this, we're going to have 6.004283 minus, we put this inside this function, put this as x and this as x for f prime of x. We're going to have 0.002143. Just like you are dividing the error by 2, that's what I noticed. If we do that, I'm going to have 6.002142. The error is reducing by dividing by 2. So the error is now 0.002142. So let's move to the 10th iteration to see. The error should be 0.001 by that time, so we can stop. Oh, n is 8 here, sorry. 8. The 10th iteration, n should be 9. So talking about x10. Should be equals to x9 minus f prime of x9. Sorry, f of x9, not f prime of x9. F of x9 divided by f prime of x9. What do you get for our x9? That's 6.002142. That's 6.002142 minus f of 6.002142 divided by f prime of 6.002142. So we calculate this. You have 6.001071 as the final answer. And if you take your error should be like 0.001071. So for this, I believe it's just low. It's low enough. We can stop here. So let's move to the next question. So this is our answer. They said using an initial value of 7, it shows that the answer to this root of this equation is 6.00. If you continue, the answer will actually be 6. As the iteration tends to infinity, the answer will be tending to 6. So let's look at another guess. You have to find the other root by taking another initial guess. So now to find the other two roots, we use other initial guesses, but we are not given. So to help yourself, actually, don't make guesses that are too big. Find a way to find a solution to these equations, something that is close. You know that -4 is a solution to this. -4 is a solution. If you put -4 here, that will be -4 raised to power 3. If you know how to find solutions, then -8 into -4 square. I just take that random guess to know what the solution to that equation is actually was. Then plus 144. You can do that in exam too. Once you know your first solution, which is around 6, then you can find the other two solutions. So now this will give me 0. Then since this gave me 0, I am sure that -4 is a solution to this root. So I can just make a guess of maybe -5 or -3, something that is close to -4. I can even make -3.5, something I know that is close to this -4, so that I can get the root fast. So I'll not be doing long iteration. This is why we do long iteration, because this 7 was not converging easily. Assuming it has been 5 that they gave us and we get to 6, it's possible it converge easily instead of this 7. So let's use a root of a guess, our initial guess now, S0. Our initial guess for the other root we want to find now is, I want to try -3. So when x0 is -3, you're going to have x1 to be equals to x0. For your first iteration, sorry, let me follow it. For the first one, when n is equals to 0, you're going to have x1 when n equals to 1, sorry, you start from, you have x1 when n is 0, you have x1 to be equals to x0 minus f of x0 divided by f prime of x0. So that will be, what's our x0 now is -3. That's -3 minus a function of -3 divided by f prime of -3. So we solve that, put this inside this equation, you're going to get -3 minus 1.28571. So that's -4.28571. The error is still high. The error is close to 1.2 something. So we still have to go to the second iteration. So let's go to the second iteration. When n is equals to 1, we have s2 to be equals to x1 minus f of x1 divided by f prime of x1. So we're going to have, what's our x1? Our x1 is -4.12857, so -4.12857 minus a function of that, -4.12857 divided by f prime of that number, -4.12857. 571. So if we do this, you're going to have minus 4 x2 now be equals to minus 4.128571 plus, when you calculate this using this, you have plus 0.209604. If you calculate this, you're going to have your x2 to be equals to minus 4.00898967. So it is converging. The error is now around 0.2 also, but the next error you see it to be smaller than that. So this is 0.8967. So let's go to the third iteration. When n is 2, you're going to have x3 to be equals to x2 minus f of x2 divided by f prime of x2. What's our x2? Our x2 was 4 minus 4.008967 minus a function of that number minus 4.008967 divided by f prime of that number minus 4.008967. So we press that in calculator, your x3 now after the third iteration is minus 4.008967 plus 0.008951. So you calculate that your x3 will be equals to minus 4.000016. You can see the error is very low, so minus 4 is the answer. So that means you can stop here. But if you are given a boundary of error, please make sure you get to that boundary. If the error says it should be less than 0.8, so don't stop here. You have to keep moving. Now, the error here now is this x3 minus x2 minus this one. So if we subtract that, I'm going to get 0.09 as our error. Our error is 0.09. How did I get that? That's this value, the new value we have minus the previous value. That's what we are using it. So minus 4.000016 minus this. That will be this minus this plus 4. So you are going to get 0.009, which is agreeably small. That's like an error of 0.01. So you can stop there. I approximate this. But if the error said you should go to 0.001, you still have to keep moving because this is bigger than this. The error you got now is bigger than this. So keep moving till you get to where the error is. But in this case, we are not given. But we know that this error is actually small, which is 0.09, and that's why we stop there. So we'll move to the next guess. The question asks us that value of x after the first iteration. Remember when we did the first iteration here, we got 6.521739. That was the value of x after that first iteration we did. After putting, when we did f of, and when we did x naught, x1 to be equals to 7 minus f of 7, because the initial value was 7 then, over f prime of 7. So that was what this question is asked, value of x after this first iteration. Now the smallest root is this minus 4.00 that we got. minus 4.00016. That's the smallest value. Then the middle root. You see, that first root we got, that's 6.001. It is, how will I put it? It is an equal root. This question has the same root at the same point. That's why you have to know the root of this equation. If you don't know the root of this equation, you will not get it. You keep guessing another value and you will not get the root. So it has equal roots. One of the roots are equal, which is 6 and 6, and one is 4. You can solve this problem online and you can see cubic calculator. Not this. Cubic function. Okay, cubic equation calculator. So for that question, our A is 1. Our A is 1. Our B is minus 8. A is 1. B is minus 8. Our C is minus 12. And our D is 144. Calculate this. We need to have minus 6, 6, and 6, showing that we have two equal roots. One of the smallest one is minus 4, and the middle one 6, largest one 6. So that's how it is. Let's move on to the next question. Problem 4. We are given a cubic equation again. We are asked to find the root of this equation between this interval. So that means the answer to this question should be between 1.25 to 8.5. It should not be more than that. So the answer should be between this value. Then the answer to this value will be neglected. So the root of the equation must be between 1.25 to this. I want to use the bisection method to determine the value of x after the second iteration. So they said stop after second iteration. What's the value of x after the second iteration? So when that in that case you are finding s3. In that case you are finding s3. Now bisection method has some rules. And okay, let's look at the initial guess they gave us, the root interval, which is this. The root is between this and this. So now let's look at the function at 1.25. We want to see what is happening at that function. So putting 1.25 here, I'm going to have 1.25 raised to power 3 minus 12 dot, okay, let me use times 1.25 raised to power 2 minus 22 times 1.25, then plus 396. When you're using bisection, first find the interval that you are given, find that interval. So the second one, 8.5. The function of that interval, you have to find it, 8.5, which is equals to 8.5 raised to power 3 minus 12 times 8.5 square, which is this, then minus 22x, which is minus 22, times 8.5 plus 396. For the first one, which is 1.25, f of 1.25, what do we have? That is equals to, if you calculate this, you're going to have 351 0.70, which is positive. Good. A positive number. Let's look at the second one. F of 8.5, which is minus 43.870, which is a negative number. Good. One of them has to be positive, one of them has to be negative. If both of them are positive, that means the answer to that question, the root of that function, is not within that range. So you can't use bisection. That means the root is not within that range. If both of them are positive or both of them are negative, one has to be greater than 0 and one has to be less than 0. That's the one rule of bisection. F of A, either f of A is less than 0, then if f of A is less than 0, that means f of B is greater than 0. Or if f of A is greater than 0, then f of B should be less than 0. That's the rule. So one has to be positive, and since it's positive, then we can apply our bisection. So our first iteration now, we'll bisect the roots. That's x1 to be equals to 1.25 plus 8.5 divided by 2. That's bisection, the average. If you divide this, you're going to have 4.875. So this is the new x. So now let's find the function of this x that we got. F of 4.875. We put that back into this function. That will be 4.875 raised to power 3 minus 12 times 4.875 all square minus 22 times 4.875 plus 396. If you calculate this, you are going to have f of 4.875. Press all of this in calculator. It's going to give you 119.4, which is positive. So now, in the previous one, our previous root was 1.25 and then 8.5. That was the previous root. And one of them was positive. This was positive, while this was negative. Now we found the middle, which is 4.875. Now the middle is positive. So now we said one of it has to be positive, one of it has to be negative to be a root. That means our new root is between these two. Because this is positive, this is negative. So this is where our new root is, within this place. So the new root now is between 4.875, so 8.5. This is where the new root is, whereby this is positive, or this is positive, no, negative. 4.875 gave us positive, no, negative, whereby this is negative and this is positive. Sorry, 4.85 gave us positive. It's 8.5 that gave us the negative. Sorry. So this is where our new root is now. Let's go to the second iteration. second iteration, our S2 will be the average of these two, which is 4.875 plus 8.5 divided by 2. If you do that, you're going to have. The reason why we can do this is because we already know that this is positive, this is negative. That means the root is in between them. So that's why we are going for the second iteration, to know where. The reason why we did this to know where the root will lie. So we divide this 4.875 plus 8.5 divided by 2. We need to have 6.6875. So now we need to know where this falls. This 6.6875. We need to know where it falls. So the function of 6.6, this new root, 6.6875. Where does it fall? Let's put it here. That will be 6.6875 raised to power 3 minus 12 times 6.6875 raised to power 2 minus 22 times 6.6875 plus the 396. If you calculate this, your f of 6.6875 will be equals to, when you calculate that, that's 11.28, which is positive. So let's go back to, this is the new range. Now, our new range now, one is positive here, which is 4.85. One is negative here, which is minus 8.5. But the middle, the bisection that we got is also positive. So that means the new answer is between this positive and this negative. As this has been negative, the answer will be between this and this. But since it's positive, that means the new answer is between this 6.6875 and 8.5. So the new answer now is between 6.6875 and 8.5. So the new answer is between 6.6875 comma 8.5. So that's the range of the roots. Then we can find x at that point, our x3. So for the, when we are, as if we are finding s3 will be 8.5 plus 6.6875 divided by 2. And when you do that, so I made mistake in the calculation in the notes. So this is what is meant to be. It's between this and this, not this and the previous one, because this is positive also. It can't be between the two positive numbers. It's between the one positive and one negative. So in the notes, I made a mistake. It is going to be 8.5 plus 6.6875. So let's do calculator. That's 8.5 plus 6.6875 divided by 2, which is 7.59375. So you can correct that. This is what the root is meant to be, 7.59375. So that's that. Correct the mistake. One has to be positive, one has to be negative. Let me explain again. You see, this 6.6875 is, okay, let me start from here. 4.875 is positive, right? Then we got 6.6875 as a bisection, which is also positive when we calculated it. Then 8.5 was at the end, which is negative. So the mistake was that I picked this and this, which is wrong. You're not supposed to pick positive and positive. It should be positive and negative. Inverse. So it's meant to be between this and this. That was a mistake. It's not meant to be this plus this. So you can correct that. So let's move to the next question. So that's our x3 that is required. Problem 5. We are given this equation and we are asked to use Jacobi iteration like the first one we did, and we are asked to show all our error, all the error we got. We are asked to show them. So see the same procedure, same method, nothing changed. And we are also asked to use Excel to solve it. So I'll use Excel to solve it too. So let's start with the Jacobi before we use Excel to solve it. Now, okay, we are asked to do 3 iterations. So don't forget 3 iterations, showing the error for them. So now we are going to do the first, the second, and the third. Now, this is the equation that we have. 4x1 plus 2x2 plus x3 equals to 32. So we want to perform Jacobi iteration for just 3 iterations. Now let's check our diagonal. Is it dominant? I want to check our diagonal. Is it dominant? Let's look at this 4. 4 is greater than 2 plus 1. Yes, that's dominant. 1. Is 1 greater than 7 plus 1 here? No, this is not dominant because the diagonal of this has a coefficient of 1, while the sum of this 7 and 1 is 8. Note, it's not minus 7, it is 7. We are using the absolute value. So this is not diagonal dominant. What about this 2? 2. 3 plus 8 plus 3 is 11, is not dominant. But you note that this is dominant. Why this is dominant? So we have to change this equation. So equation is like 4, 2, 1, then 1, 1 minus 7, then minus 3, 8, 2. We are not swapping numbers like changing 2 to this or changing 3 to this. We are changing the equation. We are bringing equation 2. This equation 2, we are making it equation 3. So equation 2 becomes equation 3, and equation 3 becomes equation 2. That's what we are just doing. We are not changing the question. We are only swapping the equation. So that will be 4x1 plus 2x2 plus x3 to be equals to 32. Then x1 plus I want to swap it. That will be minus 3x1 plus 8x2 plus 2x3 equals to 63. If we do not swap it, the function will not converge. The Jacobi iteration will not converge. We're having higher errors, and higher errors. Then you have x1 plus x2 minus 7x3 equals to minus 17. So always make sure that your matrix is diagonally dominant. So with this now, it is diagonally dominant. We can write our equation that we're going to use to solve the question. So for your x1, let me rub this off. Just know that this is our equation 1. This is our equation 2. Equation 3. We've turned this to equation 3. And this is equation 2. So let's write our x1 for equation 1. x1 that we'll use to solve the problem. x1 is 32 minus 2x2 minus x3 divided by 4. And we have for equation 2, this is equation 2 here, equation 2, x2 to be equals to 63 plus 3x1 minus 2x3 divided by 8. Then also our x3 is equals to minus 17 minus x1 minus x2 divided by minus 7. If you divide everything by minus to rearrange the equation, it will be plus, 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 plus. So that means your x3 can be 17. Your x3 can be, if you rearrange it, can be 17 plus x1 plus x2 divided by 7. So these are our three equations that we use to get all our answer, and it is Jacobi iteration. So let's look for the first iteration. What's our initial value? Our initial value is 0, x1, x2, and then x3. We are given 0, 0, 0 transpose, which is 0, 0, and then 0. That is our initial value. So from there, you can take first iteration, which is our x1 be equals to 32 minus 0, so divided by 4, that is 8. Our second iteration x2, that will be 63, 0. Notice that this is Jacobi. We are not going to use this value. It's only when we are doing Gauss Seidel that we are taking the new x1 value. So we are still going back to our initial value, 0, 0. So 63 plus 0 minus 0 is 63, then divided by 8. That's 7.875. Let's calculate our x3, which is, what's our x3? 17 plus 0 plus 0, which is 17 over 17, which will give us 17 divided by 17, which is 2.429. So this is now our new value for x1, x2, and then x3. So we can go for the second iteration because we are asked to do 3 iterations. So for the first iteration, our new value is now, oh, we have to calculate error of each case. Error in each case, sorry. Error in each case. So we want to calculate the error in each case. Oh, these are our initial value, 0, 0, 0. Then don't forget that we got the new value of x1. The new value of x1 coming, x1, the new value, x2, and x3. These are the new value for x1, x2, and x3. It was 8, 7.875, and 2.429. So with that, we can calculate our error. What's formula for the error 1? Error 1 is equals to x1 new minus x1 old, the absolute value. What's our x1 new? That's 8 minus 0. So the error 1 is 8. Error 2 also would be absolute value of error 2 new minus error 1 old, which equals to, what's error 1 new? That's 7 7.875 minus 0. So we subtract that, our error 2 is equals to 7.875. We can calculate our error 3 too. That's the magnitude of error 3 new minus error 3 old, which is 2.429 minus the old one, which is 0. The old one is 0. And we subtract that, your error 3 after first iteration is 2.429. So we calculated all our error, then we can go to the next iteration, which is iteration 2. So let's move to the second iteration. For the second iteration, we'll go back to our x1, x2, and x3 again. Let's find x1. x1 is equals to 32 minus 2 times x2. What's our x2? The new one I want to use, that's 7.875. Then minus x3. What's our x3? 2.429. Then divided by 4. If you calculate that, your x1 new will be equals to 3.455. 3.455. We can calculate our x2 too like that. Our x2 will be equals to 63 plus 3 into x1. What's our x1? 8 minus 2 into x3. Minus x3 is 2.429. Then divided by 8. If we calculate that, our s3 will be equals to, our s2 will be equals to 10.268. So that's our s2. With the same procedure, we can calculate our x3. What's x3? x3 is 17 plus x1. That's 17 plus 8, which is x1, plus x2, which is 7.875. 7.875 divided by 7. If you calculate that, our s3 will become 4.696. 4.696. So we've now our new x1, x2, and x3. So we need to calculate the error. So our new x1, let's take off this. Now our new x1, x2, and x3 already. Our new x1 now that we got. Okay, let's go back. These are previous x1. Let's write our new x1 here. Our new x1, x2, and x3. x1 that we just got now is 3.455. And the x2 that we just got now is, what's the x2? 10.268. We rewind, 10.268. And the x3 is 4.696. So with that, we can calculate our error, the new minus the old. So error 1 is equal to magnitude of error 1 new, value of x1 new, and then minus x1 old. So we do that. What's our x1 new? That's 3.455 minus 8. This will give us a negative number, but we are taking the absolute value. So 3.4558, 3.455 minus 8. That will be 4.545. So that's our error 1. Still very high. Error 2 now will be equals to the magnitude of error 1 new, error 2 new, sorry, minus error 2 odd. What's error 2 new? That's 10.268 minus 7.875, which is the odd one. We subtract that. 10.268 minus 7.875, you have 2.393, which is our error 2. From there, we can calculate our error 3. Our error 3 is S3 new minus X3 odd. What's the new value of S3? That's 4.696 minus the old one, 2.429. If we subtract that, 4.696 minus 2.429, you're going to have 2.267. So that's our error 2 after the second iteration, and this is our new x that we use for the third iteration. We have to estimate the solution after the third iteration. So let's do the third one and see the answer there. So the third iteration, let's leave our x1, x2, and x3. This is the initial guess. After first iteration, we got this. After second iteration, we got this. So I'm going for the third one now to see what we're going to get. And this is our new guess now. So our S1 now will be equals to 32 minus 2 into brackets. What's x2? 10.268 minus x3. What's our x3? 4.9696 divided by 4. If we calculate this, our x1 is equals to x1 will be, so if we calculate this, our x1 will be 4.6. When we calculate, you're going to get 1.692. You calculate that very well. And our x2 now will be equals to 63 plus 3x1. What's our x1? That's 3.455 minus 2x2. That's minus 2s3. What's our s3? 4.696 divided by 8. So that means our s2, if we divide that, get 7.928. 928. So we can get our x3 too using the same procedure. S3 is equal to 17 plus x1. What's our x1? 3.455 plus our x2. What's our x2? 10.268 divided by 7. If you calculate this, you're going to have 4.389. So after the third iteration, the solution is approximately x1 is equals to, I want to leave it in 2 decimal points, 1.69. After the third iteration, x2 is 7.93 and x3 is 4.39. So these are our x1, x2 and x3 after the third iteration. We can also calculate the error using the same procedure. You just use the new value, this new value minus the old value. That will give you 1.763. That's your error 1. Error 2 now will be this value 7.93 minus this, and that will give you 2.34, and that's your error 2. Your error 3 will be this value minus this value, and that will give you 0.307. That's actually the lowest error, showing that the equation is converging little by little. So we have to repeat this problem using Excel, showing the iteration, the solution vector for x, or the x, and the error vector for each iteration. That means error for 1, error for 2, error for 3 in each of the iteration. So we're going to do that. So actually there's something we call overall error, whereby I can find error for all the error. You take the absolute value of it, e square 1 plus e square 2 plus e square 3, and take the square root. That's the absolute error for that case. So let's use Excel. Solve the problem. I'm thinking I should copy and paste the problem here, so we know we're coming back here. Let me rub off all of this. We need our equation. So don't let me rub our equation off. That means we have to come back to this. We need this equation. So now we have to use what? Iteration k. So let's talk about the iteration. Let's the iteration here. Iteration as k. That's that. So now the first iteration 1, I'll put it as 1. Then the next iteration, this is the first iteration, which is 1. So the next iteration will be equals to add 1 to this previous value plus 1. So that will be 2. If I take that down, we keep adding 1 to the previous value. So if I take it from this, can you see that line? Take it down like that to anywhere you want to stop. What this means that it copies this formula to this place. Now this is now 6 plus 1. That's it, add 1 to this place. Now this 7 plus 1, add 1 to the previous number, add 1 to the previous number. So that's how it should be adding it. If I want to continue, I still go back to that line, that last end, extend it from there. So that's that. So after the iteration, we need the x value. Showing the x value, we need the x value. The first one is this. So let's write the equation for that. Let's x1. Let me make it at the middle. Control the center. So the first value is, we want to talk, the first value of x is 0. That's the initial guess. that we are given. X22, the first value is 0. That's the initial guess we are given. The X3, you can't calculate that, is what we are given. It's also 0. That's the initial value that we are given. And we have to calculate error. So this is not our first iteration. If this is 0, 0, what we get here, that'll be our first iteration. That means this will be 0. So that means there's no iteration here. This is where the iteration starts from. The first one that we get here is the first iteration. That's because if we go back to the solution, when we have 0, 0, 0, there's no iteration. It's when we now start with x1, which is our first iteration, to get all this value after x1. Then error. We're going to have error 1, error 2, then error 3. How do you calculate your error? Your error is, okay, your error is actually x1 new. So this is the new value minus what is here. So let's calculate that. That will be equals to, I'll click on where I want it to calculate. I want it to calculate say this minus this. So, and I want the absolute value. I don't want so the absolute value of, that's ABS, the absolute value of that number. This, anything that is here, minus anything that is here. So that's that. It will calculate the error like that. There's no value there, that's why it's still giving us this. So I can take it down. So to keep doing it for everything, can you see the formula is changing? D10, D16 minus that, the previous value minus, take D6, the previous value, the next value minus the previous value, and take the absolute of it. If we go to this place now, it will be take this one, 7 minus this one. So let's do for this to E2. E2, that will be equals to the absolute value of the next value, E2, minus the previous value, E1. That's the formula for that too. Let me take that down. E3 also the same thing, equals to the ABS of the next value minus the previous value. And take that down too. I've calculated all the error and control all. Put everything in middle. And good. So now, how do we get our new x1? What are we going to do to get this new x1? What we used to do is that we do 32 minus 2x2 minus x3 over 4. So that's what we want to do here now. 32. That will be equals to, shift bracket, 32 minus what? Minus 2x2. That's minus 2 shift times this times in Excel times x2. x2 is what? This x2 that we are talking about, the previous value is 0 here, right? Don't always forget that. That x2 is the previous value from this 0, 0, 0. That means it's the previous value. So it's talking about this value here, the previous value of x2. The initial guess. That's that. I'm clicking on it to bring it E5. It's going to be solving it as E5. Then what again? Minus x3, which is also this previous value, minus, I'll click on it, x3, then close brackets, then divided by 4, divided by 4. I'm going to calculate it as 8. And if you notice, we got 8. So I can also swipe down to 23. So it will make the formula like that for everything. You can see the formula is changing up. It's 20 minus F20. So like that. So let's look at our S2. What's happening in our S2? Our S2 is 63 plus 3x1 minus 2x3. That will be equals to bracket 63 minus shift bracket. Okay, it's plus 3x1 plus shift plus 3x1 times 3 times x1. This previous x1. As it is Gauss Seidel. You know, the x1 I want to use to be this. So click on this. Let me explain again. You get that. You know, why is this value not there again? Come in. Okay, it's there. Now, equals to brackets. We said 63. Shift plus 3x1. 3 shift times x1. That x1 is still this previous value. We're not doing Gauss Seidel.
is Jacobi, so it's the previous value and the initial guess. But I'm saying that assuming it is, what's his name? Gauss Seidel, I want to do. That x1 has become this 8 here. We'll have pressed 8 like this. But we are doing Gauss Seidel, so we press this. The previous value minus 2x3. What's our x3? Minus 2. Minus 2. Shift star x3 times x3. x3 is this x3, the previous value, then divided by what? Divided by 8. And that's that. If you check what we got earlier, it will be 7 point. Let me see if it's still there. It's not there again. Can I go back? I can't go back to that again. Can't go back. Can't go back. So let's continue. Now, what about x3? How do we calculate x3? x3 is 17 plus x1 plus x2 divided by 7. That will be equals to bracket 17 shift plus x1, shift plus x1, shift plus x2, x2 divided by 7. You calculate it, and that's what we got earlier. We can take this down to see what we have. We can also take this down to see what we have. You can see that the answer is converging. When we get to this place, we are getting 3.7. We go down more for more iteration. You see that the answer will convert to a whole number. Now, don't look at that. It has converged after the 25th. At 25th iteration, we have 384, and the error is very small. This error is very, very small. The error is 0.0000 something. I don't know why this one is giving us this. What's the formula for this? D38 minus D37. D38. It should be that. Oh, there's no value in D38. That's why we are not. There's no value here. So that's why this one is giving us this error here. No value at this. So let's change the formula to absolute value of what is here minus what is here, so that we don't have something like that. Absolute value of this. Let me go back to that so you can know what I'm talking about. Ctrl Z. What happened is that subtracting a value here, so you're seeing it as 0 minus 3. That's why the error is big. It's seen as 0 minus 3. So I want to go and change this formula to not the next one. It should be the previous one minus the next one. So it will not do 3 minus 3. You see that all this one will be 0, 0 or something less than 0. So let's see. Let's come back to this. So instead of this to be D5, this minus this. Do the same thing. This for these two be this minus this equals to, then this also be 5 minus this equals to. So we can still drag the formula down, make it apply to everything. See that it changed now. It doesn't change. Don't know why. It should have changed. I've already dragged the formula down. Something did not change. Are you telling me the formula does not apply? It should apply to it. Why am I? What's now this? F37 minus. That means the formula is not applying to it. The formula I just did now. T5 minus this. So that should be This 5 minus this is this minus this. Let's look at the second one. This 6 minus this 7, it applies now. This 7 minus the 8. No, what do I do for here? I want this to subtract the next one. This to subtract the next one. So when it gets here, this we want to subtract the next one again. Let me see. D37 minus D38. I don't want it to get to that. I don't want it to get to that. It's not meant to get to D38. Am I having that error? Even if I'm using, D5, D6, this minus this minus this minus this. Now let me refill the formula and let me see what is going on. This should be 37 minus 36, not 38. Not the next value here. D5. This error I've got here. Okay. The error is meant to start from here. This error is not supposed to be here. It should be 8 minus 0 and it should record it here, not up. So that's why we're having that. Let me see if I can shift this down by one cell. Insert cell, shift down. Okay, I can shift it down. Insert cell, shift down, and shift down. Insert cell, shift down. So it's meant to be, the error is meant to be 8 minus 0, which is this 8. This minus this, which is this. This minus this, which is this. So that's the error. So now we can re-edit this as to the last place that we are going to. This is not meant to be there again. So that's that. That's the error. So the last page is not meant to be there. So we can continue. No, let's analyze it the way the question wants us to analyze it. It said, repeat the previous problem using Excel. Continue the iteration until E max is less than. So we want to stop at, we want the error to be 0.00001. 0.001. Want the error to be less than this. So let's go to our error. That's where it's from our error that we'll know where to stop. So let's go to our error. Where is it? Yeah, this is what we just did. Then where is the error? Is 0.001. Look at from here. It's not still more than that because the error is not yet 0.001. This one is 0.0015, which is greater than where they say we should stop. So we can't stop here. We can't stop here. But we look at this 15. The error is less than 0.001 because this is 0.00038, and this is the maximum. Okay, this is the maximum, and it's less than that. So we can stop this. We can discard all of this. We can delete all of this. This is where the error is actually less than that 0.001. That's why you have to stop there. They said continue the iteration until E max is less than this. And what's the E max here now? The maximum error here the maximum error here is 0.000748, which is less than what the E max is. Then we can stop there. So we stop after the 15th iteration. It's after the 15th iteration that the error is less than this. So we can continue. Let's move to the next question. We are asked to use Raphson Method to find all four roots of this of this equation. We know what Raphson method is all about. It's all about the function, which is f of x to be equals to 4x. Okay, let's just call this f of x. I don't need to write it again. This is our f of x. The note, we need f prime of x. We need the derivative of f. So we need to, this is our f of s. We need the f prime of x. We need to differentiate that. So if we differentiate this very well, you should get 4 cos 2x. I know you are very good with differentiation. 4 cos 2x minus 8s sine 2x minus 2x plus 4. So we differentiate that. We are going to have this. So this is our differential and this is the function. So with that, we can do our first iteration. And note, they said for the smallest root, show all your hand calculation. Continue the iteration until e is less than minus 5. So we are asked to do this for the smallest root. Then I made a mistake taking the initial guess to be 7. Because if you are saying for the smallest root and the answer is between this and this, so I should have taken 2 or 3, number that is close to this small interval. But I picked 7. I did not see this condition here. So for the smallest root, I'm supposed to take a number close to 2 to do our iteration. And let's take s equals to. So we're going to start with the small interval. So let's start with s equals to 2. So our s naught is 2 now. So that's what we're going to use to know our root and the error. I told that the error should be 0.00001, 1, 2, 3, 4, 5. So that should be our error. So we'll start with that. So let's start with s naught, the initial guess, to be equals to 0, to be equals to 2, sorry, the smallest interval. So that means our x1 now be equals to, no, the formula is xn plus 1 to be equals to xn plus f of xn divided by f prime of xn. So when n is equals to 0, we're going to have x1 to be equals to x naught plus f of x naught, sorry, there's a mistake, divided by f prime of x naught. There's a mistake. It is not plus, it is minus. The formula is minus. So that will be x naught. What's our x naught? That's 2 minus f of x naught. That's f of x naught. That's f of 2 divided by f prime of 2. So if we take that, that will be 2 minus 4 times 2, that's 8. 8 cos 4 minus 2 minus 2, that's 0. 0 square divided by 4 cos 4 minus 8 times 2, that's 16 sine 4 minus 4 plus 4. If you have that in your calculator, that will be 2. And make sure your calculator is in radian. It's in radian. Calculator. That will be 8 cos 4. Let me change it to radian, degree, radian now. 8 cos 4 divided by brackets 4 cos 4 minus 16 sine 4. That's minus 0.055. That's minus, everything gave him minus again 0.5557. I want to stop to how many decimal points is our error? 1, 2, 3, 4, 5. So let me stop in 5 decimal points. 0.550769. Let me stop in 6 to be able to see 69. So we do that. 2 plus that, that's 2.550769. So that's our x after the first iteration. And if we check, where is it? 2.550769 with the calculation when the initial guess was 2. That's our x. Now we have to go for the second iteration. The second iteration, that will be x2. Now your x2 now will be equals to x1 plus f of x1 divided by f prime of x1, which is equals to, what's x1? x1 is this new value. That's okay. The error, we did not check the error, but we know that the error is I can, that's this minus 2, that's 0.5. Oh, way higher than our value that we are looking for, 0.0001. This is 0.5. That's 2.550769 minus f of 2.550769 divided by f prime of 2.550769. So we calculate this. I'm not going to write, I'm just going to press it in calculator once. Minus, I'll solve all this in calculator once. I'm going to write it 2.550769 equals to, so I have it as an answer. Then it will now be, what's my x? 4 times x, that will be 4 brackets 4 times answer, shift answer, cos 2 times shift answer minus brackets shift answer minus 2 brackets all square, and I close the brackets, divided by brackets the f. I'm going back to the f prime now, which is this. That's 4 cos 2 times answer 2 times shift answer minus 8 times answer 8 minus 8 answer minus 8 answer sine 2 shift answer sine 2 shift answer sine 2 shift answer minus 2 shift answer plus 4 close brackets. So that gave me 0.184889889. If you calculate that, minus 2.550769, that's 2.365890. So that's the answer. Let's check if 2.36588, that means almost the same thing. 2.8, that was 90. That means there's an approximation somewhere, because this is, how would I put it, this is a computer solving it. I know you're using calculator, so that's that. So we have this is our new value. If we subtract it from the previous value, so that the error is still 0.1, not get to the accuracy that we want. So we go to the third iteration, which is S3. S3 equals to x2 plus fx1 divided by f prime of x1. S2, not s1, s2. So our x3 now, because what our x2, that what we got earlier, which is 2.365,890. Okay, it is 880. I made mistake. It is 8. If you supply this, you get 880, not 89. 880. That's what we are going to have. 880. So 2.55, 880. I'm writing plus, it's minus. Why am I writing plus? Minus f of 2.365880 divided by f prime of 2.365880. So I'm going to write everything once again in the calculator. So that means my x3 is equals to, let's do that, 2.365880 equals to, now that will be, put it in f of x, open brackets, 4 shift answer, open bracket, 4 shift answer cos 2 shift answer minus bracket shift answer minus 2 bracket close square, close the bracket, and divided by the other one, which is f prime of x, 4 cos 2 shift answer, 2 shift answer minus 8 answer minus 8 shift answer sine 2 shift answer. I'm pressing everything once. Shift minus 2 shift answer plus 4 close brackets. Make the answer very big. 1.6. That's too big. 4 answer cos 2 answer minus answer minus 2 square divided by 4 cos 2 answer minus 8 answer sine 2 answer minus 2 answer plus 4. That's way too big. After pressing the calculator again, I got 2.36580. Then this gave me minus 0.006 plus 0.0063306. So we add that, our x3 now, our x3 will be equals to 2.36580 plus 0.0000, that's 0.00 shift answer, 0.00 h3, okay, 2.36580 plus 0.0006306. So after careful calculation and writing the equation, I got all of this to be 0.002706. So you can confirm that too. So that means our x3 now, if we subtract that, 2.36588 minus 0.00272706. That will be 2.363174. So this is now our x3, 2.363174 as our x3. So the error is now 0.000.002, which is still greater than this. So we can't still stop here. We'll keep moving forward. So let's go to the fourth iteration. Let me take off some of this. I'm taking off the fourth iteration. This is the formula. So x4 now equals to x3 minus f of x3 divided by f prime of x3. And our x3 is what? Our previous value for x3 was 2.363174, I think. So this is our new value for x3. So that we're going to use 2.363174 minus f of 2.363174 divided by f prime of 2.363174. So let's press this in calculator, and I hope I won't be mistake this time. 2.363. We never confirm this 2.3363174. Let's confirm it with our Excel when s was 2.363174. That is correct. So we're expecting 2.36171 now. Let's see. So that will be equals to minus. Let's take f of this. That will be, what's our calculator? We have the answer to be 2.3633174 equals to. Then we want to use that as our first shift answer. First shift answer equals 2 shift answer minus bracket 4 minus bracket shift answer minus 2 close bracket all square close bracket divided by bracket 4 cos 2 shift answer 2 shift answer 2 shift answer minus 8 shift answer sine 2 shift answer minus 2 shift answer plus 4. So the answer is 2.7. That's too low. That's 0.00000012345 12345 0 no 0.00 it is 27 or 28. So we subtract this, we are going to have minus 2.363174. So that's 2. We subtract that 2.363 171. So what's the error? Now the error here is now this new value, the absolute value of the new value, which is 2.363171 minus 2.363174. Let's check what that will give us. So the error now is equals to 2.363171 minus 2.363174. That's 0.0.0000003. That's 1, 2, 3, 4, 5, 6, which is lower than this. This 1, 2, 3, 4, 5. This 3 times 10 to the power minus 6, and is lower than 1 times 10 to the power minus 5. Then we'll stop here. They say continue the iteration until the error is less than this, and the error is less than this at this case. So this is our answer. That's 2.363171. At that point, the error is less than that. So that's where we're going to stop. So this is the first solution. Now we have to use Excel to solve it. So let me rub off all of this. We need the differential equations. I'm not going to take it away because we need it to solve the iterations. So I'm not taking it. Okay, I can take up the formula. I'll write the formula again. The formula is xn to be equals to xn plus 1, xn plus 1 to be equals to xn minus f of xn divided by f prime of xn. So this is the formula that we need. So let's open Excel. A new Excel, no, not this, not this. Save Excel, a new one. So I want to use Rapson method. Using Rapson method. What do we need? What do we say we should do? Let me go back there. We need to find the other three roots. Other three roots. That means there are other three roots. This equation has 4 roots. So say use Z to find other three roots. We already used Z to find the roots when it was 2. When our guess was 2, we found the roots. So we're going to use Z to find any other guesses between 2 and 8. All the guesses will be between 2 and 8. So let's look at when the guess is 3 from Excel, we see. So we need include in your summations iteration. So the first thing we need is iteration as a function of, let me give space because we need 3 iteration, we need 3 solution. This iteration, so let's assume this is 0. So the next one will be 0 plus 1. I think the iteration starts immediately, so let's take it to 1. That will be the next one will be equals to a formula that is equals to this plus 1. So we can take it down like that. So we need it for 3 cases, for 3 different cases. Control Z, I don't want that. Control C. Let's say this is the second place that we are using. I want to write the 3 equations as once. And then let's say this is another one here. No, that means there's too much space here. Control V. This one should be deleted. Then the other one to be here. Control V. No, okay. Control C. Then Control V. Then this is 1. I'm writing all of them at once. This is 1 also. Then let me put everything together as a center. Control Z. Okay. Let's move on. Control All. Center them. And good. Now, this equation should also come here. Control V. This equation should also come to this one. here, Control V. This is 1 here. We can change that. So the first 10 iteration that we are using, we want to delete some. So I'm through with the iteration aspect. The next thing is for us to know, we want to know, they said submit table including k, f of x, the value of f of x. So we want to know the value of f of x, we want to know the value. So now what's the formula for f of x? What does f of x say? That was a 4x cos 2x. So now that'll be, let's write the equation here. So we need, before we can find the value, that means we need x first. We need the initial guess. So let's assume that, let's call this x. Let's call this the x, which is the initial guess, or the iteration, the answer that we got. Or where do you want to put the iteration, the error? Okay, the x should be, okay, that will be the initial x, and the one that we're looking for will be the final x. Okay, this is the initial x, Control C, Control V, no, Control C, Control V, then Control C again before you move, Control C, then Control V. Then what's our initial guess? This is the value that we'll put there ourselves. The initial guess. It doesn't actually have usefulness. Let's take it away. Control Z. Let's just put it here. Initial guess for the first question. Initial guess equals to initial guess, Control C, Control V, and then this one is upper than this. Let me push this one down by 1 bit. Insert cell, shift down, good. Let me delete, let me Control X this, and let me Control V it here. Let me push this one to down by 1 cell, insert cell, and let me Control C this. So that will be the initial guess for each of them. We'll put the value here. So let me just put any value 4. Initial guess for this 7. Initial guess for this 5. So I put all these initial guesses. Then we need f of x, as I said. What's our f of x? F of x. We need f of x here too. F of x. We need f of x here too. F of x. Let's write the formula for f of x. Our f of x is 4x plus 2x minus x minus this. So let's write it. Our f of x is equals to bracket 4 shift times x. What's our x? Our x is that initial guess. Remember, this x is the initial value of x not that period. So that's our initial guess. So that'll be this 4 times that, then times cos 2s, shift times cos bracket 2 shift times x, and this is still the same x, close bracket. That's, we are true to this place, minus x minus 2x minus bracket x minus this. So minus bracket x, this is the same x, minus 2 bracket close, everything is part 2. So that's it. What's that? A typo? Where is the typo? That means this is not how to write raised to power 2. Come in, let me see if we correct it. Okay, it has corrected. 4 times x cos 2 times x minus 2 raised to power 2. I did not put the bracket, I did not close the bracket finally. That's the problem. So that is correct. So this same formula, Control All, we'll copy it. Come in, get away. Control C, and we'll put it here. Control V. But don't forget, check if it is it's using this value. So J7. So we get to that, and J4, sorry, that's J row 4, 1, 2, 3, 4. It's using a J4, so it's correct. So let's do it for this too. Let's copy this, Control C, and then Control V. So the same thing happens to that. So we can highlight it down because that's the same formula we use all through. Okay, don't let us assume yet. The next thing is we need value for f prime of x. So f prime of x, f prime of x, also f prime of x. So now what's the formula for f prime of x? It is 4 plus 2x. Let's write down first. 4 equals to bracket 4 shift times cos bracket 2 times x. X is still this, close bracket, 4 cos 2x minus 8x minus 8 shift star x. X is still this, minus 8 times 2x again, shift star sine 2 shift star x again. This is x close bracket. We are here already. Then minus 2x plus 4 minus 2 shift star x. This is x again. Then shift plus 4. Then close bracket. So we have that. So let's copy it in the other ones too. If you believe, Control C, then Control V, Control C again, then Control V. So we have all of this. Then what do we need again? We need the iteration value. We need the next value, which is Sn plus 1. And it is Xn, the previous value, minus the division of f of x and f prime of x. So that will be, this value now is our new x underscore new, the new value. This is the initial guess. That will be the previous x, which is the initial one, which is this x naught, minus f of x, f of x, which we already have, f of x minus shift brackets f of x divided by this one, close brackets. So that's that. That's our new value. Copy it, Control C, Control V. There's a problem there. Control C, Control C, Control V. This one does not have it. Why is this one having a problem? Okay, the reference is not seeing the reference, so we have to write this equation itself. So this is x new. Let's copy the x new. Let me see if this one actually copied the right thing. J4, using the J4, yes. Q4. It's supposed to use Q4, not J4. So there's a mistake in this formula. That's why I say always check. It's supposed to use Q4, not this. If you check this now, the formula is saying J4. I'm supposed to use Q5. So let's check that. So we can just put Q5 directly. I don't want it to use Q5. Yes, so giving us what we want. Now let's look at this. Why is this one giving us? We wanted to use what? We wanted to use this value here, and C4. So let's add that. So we have what we would expect here. 3.25. If we go and check what we get earlier on, it should be the same thing. So let's extend the graph downward and see to 10th place. No value there. Again, no value here. Again, no value here. There's an error that's giving us this value. No value here. No value here. No value here. No value here. It's only calculating for the first one. Control Z. The other values are wrong. So let's continue. Let's calculate the error. Now error for each iteration. Let's calculate error. Now error which is E. Our error is, we'll come back to all this mistake here. Our error is the final value, absolute value of this final value minus the initial value. So that will be equals to ABS of this minus this shift bracket. So that way we're going to have Control C and then Control V and then Control V and then error, that's error, Control V and then Control V. We have that. Okay, the problem is that it's not taking the value from here. So there will be an issue. So we need to create a value for the old x. For the old x, this is the x new. For this one, the old x is 4. So this first one is correct because it took this value. Now, when you want to solve the next question, you're supposed to take this value as a new value. But it's having issue of taking this value. It's taking this again. And that's why it's having issue upon issue upon issue. So let's see if I can integrate another cell. Right shift. I'm not shifting it. Entire column. Okay. I don't want it to the left. I want it to the right. That's a mistake. Entire column. Insert entire column. Let me see if I use it here. Cancel. Let me say it's going to do it from here. Insert entire column. Good. So this should shift back. Okay, no problem. Let's do it for here too. There will be an issue. Ctrl Z, Ctrl Z, and let me start again. Insert entire column from here. Do it for this too. Insert entire column like that too. Do it for this too. Insert entire column. So that will be for our S old. S underscore old. Control C. Control V. S underscore old. S underscore old. Remember the X old now. For this one is the initial guess, which is 4. For this one is the initial guess, which is 7. For this, let me put it back. Initial guess is 4. Initial guess was initial guess 7. Five. We are going to change out the formula, don't worry. Let me see what can we do. Can we remove this space here? Delete entire column. And good. So starting from here, it ends there. So that is our initial guess here, which is 4. Our initial guess is 7. Our initial guess is, so this one is 5. So we'll change the formula now. For fx1, our x1 now is not this place anymore. It's this one, which is b7. We're using b7. So to be, this will now be b7, b7, b7. This is also b7. That's our initial guess. Now for this b7, this one's also b7, b7. I'm changing the formula because this is what we need. We need this b7. The initial guess is now here, b7, and then b7, and then b7. So that's our initial guess. This is our new x1. You can compare it with the previous one. How our new x1 is not this. The mistake somewhere. Our new
S1 should be this. Okay, our new x1 too will change. It should be this value, which is b7, now, not that one again. b7, I did it for this, b7. Then why are we having this? Okay, b7, has this changed? This 7, c7, this c7, and this d7. Okay, no problem. You can copy that, Ctrl C, and put it here. Ctrl V. Copy this again. Ctrl C. Put it for f of x here. Ctrl V. Copy for this f and put it for this one too. Copy for this one now. Ctrl C again and put it for this one. Then for your s new, copy for this one and put it for this x new. Copy for this one and put it for this x new. Then for your error, the error change, absolute value of this should be this, which is E7 minus B7. E7 minus B7. So it's still B7. So we have that. So you can copy this, Ctrl C, Ctrl V, Ctrl C again, then Ctrl V. So we have that. Let's take it down. Let's take this down. Let's take this down. Console. Let's take this down. But there's one we've not talked about. Let's take this down. Let's take this down. Let's take this down to affect everything there. So you can go down like this. Down. 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 This is trying to put all the formula together. All the formula will keep copying themselves to the next stage. And then down. So now, but it's not yet still good because this old value is not working for this. We need to know what this is. Now, this old value now is what we want this one to use in his next case. So now, and that old value should be x3. Should be this s new. This s new has to come to this, and this one will make use of it, and this one will also make use of it to calculate the new s new. So now, this place now should be equals to present this place. That's just all. So this place is now this. So you can take it down like that to keep taking the value like that. So let's copy this place, this formula we use here, to this place. So this place is now this. You can copy it down. Keep taking the new value. Same thing as this. Let's copy this here. This one is now equals to this place. This value s new is now this. So let's copy it down. That's that. So now you can see that the answer here for the error is already 0. That means at this point, this is our answer, the x new. 8, you can see it's not changing again. 8.31926. So at x equals to 4, another initial guess. After the third iteration, we've already gotten our answer because the error is already less than 0.0001 that they said. So the third iteration is giving us that answer after the initial guess. So the same thing for this. When the error was 7, when the initial guess was 7, at the third iteration at this place, we already got our answer, 6.60385. So this is the answer. Because this is less than the error is less than what they said we should use, 0.005. So at that point, this is where the answer comes in because this is greater than that. That's 1 raised to the power minus 4. Also, this is where it ends. After the fourth iteration is where we get the answer. After the fourth iteration here too, fifth iteration here, we got the answer. Now for this, where do we get the answer? After the sixth iteration. But wait,
This and this have the same answer. It's 6 points. So when you make an initial guess of 7 and an initial guess of 5, they give you the same answer. So that guess, you have to change this guess to maybe 6 to see what you're going to have. So we just change it here to 6. Sorry, 6. And see what we have. Here. I can initial guess of 6, the answers have changed. This is the answer. Let's imagine we choose an answer that is too high. Let's say we choose 100. You see, it's not converging yet. But if I keep going down, it may convert to one of the answer that we need. So let's go again for the other ones. I'll go down for this one. That's like after how many iteration. Let's go back down for this one too. Let's see what we are going to have. Okay, let's go down. I want to see where it will converge. Maybe it's going to get an answer for us. After which iteration that the error will be very, very small. This is like after 200 iteration, 250 or so. But we have to copy all of them before we are sure of where it is converging. Okay, this one I'm copying. This does not go down to so let's take for this. Anytime else we're dividing by 0. The error is not going. As we can see, it did not converge. So when you take a value that is outside the point, it does not converge. You keep iterating, and it will never converge. When you take a value outside the original value, so you must always pick value that is close to the original value. If you take a value that is away from the original value, it may converge, but it may take a longer time. But this that I'm looking at, it will never converge because it's moving higher away from the original value as I'm looking at it. So let's go back to Ctrl Z, Ctrl Z, Ctrl Z, Ctrl Z, Ctrl Z. Let's see. Okay, that's what we have. Okay, so it's sorry, Ctrl Z again, Ctrl Z, go back to 6. Let's use 10. Let's see, 10. 10 might converge. 10 might converge if we go further. Let's say if we go to like 30, let's see where maybe it's going to give us a good answer. Ten is converging to 6.305. 10 is converging. 10 is converging to 6.305. It's converging to this answer here. But after how many iterations do you have to wait? Let me see the error before you start. Before we know that, oh, we can stop. Like before we can stop, it was after 24th iteration. That's where it is 0.001. That's when the error is less than the one that they say we should stop after how many iteration. So imagine you are using your hand and you have to solve 24 times because you make a guess of 10. So when they ask you to do iteration and they say make the initial guess yourself, please guess the answer that is closer to the solution. You can always solve this problem numerically or use an idea of which answer is closer by taking some guesses yourself, put inside the equation which one is closer to 0. Any that is closer to 0 shows you that that is where the answer lies. So let me return this to our initial formal guess 6. So these are the answer 8.8 8.81 nice 3.817926. The other one here 6.60385, and the other one here, no, this is where this one stop. Yes, yeah, that's 5.83925. So those are the answer before the error is less than 0.0001. So let's move to the next question. So the last question for this aspect is talking about interpolation using Lagrange interpolation. So let's cancel everything here. So we have to use Lagrange interpolation to solve this, and we have to solve for degree 1, degree 2, and degree 3. So we use all three processes. So the first one we're going to use is degree 1. Degree 1. So the first thing is to interpolate this first before doing degree 1 or degree 2. We have to interpolate it. This is a degree 4 polynomial. 1, 1, 2, 3, 4, 5. So it's degree 4. We're going to use degree 4 interpolation for this. Let's interpolate it. F of x. Okay, the interpolation formula f of x is equals to. Now, you need to take one of the x first. We have how many x here? We have x1, x2, x3, x4, x5. We have those x5. So let's assume we are taking x1 first. So that will be f of x1. We are taking x1 first, f of x1 times, since we are taking x1 first, we will subtract x from every other number. That will be x, this x that we are interpolating with, minus the other ones. That's minus x2. We still take it x minus x3. We still take it x minus x4. We still take it x minus x5. We did not do x minus x1 because we are interpolating with x1 for now. Then divided by, we take, now x1 that we are using, we separate from the remaining 4. This x1 that we are using, now we x1 minus x2 that we are interpolating presently, also x1 again minus x3, x1 again minus x4, x1 again minus x5. We'll do the same thing. This for the first one. We are going to do it 5 times for x1, x2, x3, x4, and x5. We've done for x1. Now plus, we'll do for x2 now. F of x2 times, now since we are using x2, that means we are subtracting this x that we are given from x1, x3, x4, and x5. We're not going to use x2 times x minus x1, x minus x3, x minus x4, and then x4, then x minus x5. So divided by x minus x1, x minus x3, x minus x4, x minus x5. We did not use x2. Now that x2 that we're interpolating against, we use it against every other value. That will be x2 minus x1, also x2 minus x3, also s2 minus x4, also s2 minus x5 minus x5. Just know what is there. s2 minus x1, s2 minus s3, s2 minus s4, s2 minus s5. Now we are going to use f3. So that's f of x3. Now we are interpolating x3 now to be equals to times, there's a plus there, plus is continuous, plus that's times now, x now minus x1, x minus x2. Now, because we are using 3, there will not be s minus s3. Sorry, this is x2, s minus x2. Now, x minus x4, we're not going to use 3. Then, x minus x5. Divided by the s3 that we're using to interpolate, we subtract every other value. That will be s3 minus x1, x3 minus x2, x3 minus x4, x3 minus x5. We also do for 4. For when x is 4, that's f of x4 times, we take every other thing, x minus this, x minus this, x minus this. We will not do x minus x4 because we are interpolating x4 now. Then x minus x5. That's x minus x1, x minus x2, x minus x3, then x minus x5 divided by the x4 that we are using, subtract every other point, x4 minus x1, x4 minus x2, x4 minus x3, then x4 minus x5, x4 minus x5. So the last one is plus f of x5. So let's interpolate f of x5. That's f of x5 times, now to be x minus x1, x minus x2, x minus x3, x minus x4. It won't get to x5. That's x minus x1, x minus x2, x minus x3, and then x minus x4 divided by s5 is subtract every other number, s5 minus x1, x5 minus x1, x5 minus x2, x5 minus x3, x5 minus x4. There's a pattern to write the formula if you look at it very closely. When you are interpolating with x1, that means you're going to do x minus every other number. The point you are interpolating at x equals to one number, you separate from every other one without that one that you're interpolating with. So the next divided by x1 will now subtract the point you're interpolating, which is x1, against every other point, x2, x3, x4, and x1. So that's how you're going to write all the formula. Then every other thing is simple because you are given all the points. You are given the values for all the points. This x1, this x2, this x3, x4, x5, this f of x1, f of x2, f of x3, f of x4, and then f of x5. So with that, we can solve the problem. So how should we do it? Let's write it here. F of now is 0.9 at 0.9 because we are interpolating at 0.9 as they told us. Interpolate at this point is 0.9. So that's why I'm using 0.9. S is 0.9. All this x, they are 0.9. And you know what x1 means, s2 means. and you have f of x1 already. F of x1 is this. So let's write that. F of x1, which is 0 minus 0.49 minus 0.4459. We take it one after the other to brackets x minus x2. What's x? 0.9. 0.9 minus x2. What's x2? x2 is 0.6. 0.6 brackets again. X is 0.9. This x is 0. Oh, which one am I talking about? I'm talking about this. F of x1 is 0. Minus 0.459, which is correct. X is 0.9 minus x2, which is correct to that side. S again, that's 0.9 minus x3. x3 is 0.7 bracket x minus 0.4. 0.4 is x4 is 0.8. That's 0.9, which is our x. X minus x4, which is 0.8. Again, x, which is 0.9, minus x5, which is 1, divided by x1 minus x2. What's x1? x1 is 0.5. x1 is 0.5. That's 0.5 x1 minus x2. 0.5 minus 0.6, which is, let me just solve it like that. Okay, the next one, I'll just be solving it like that. 0.5 minus 0.6, close brackets. Then x3 minus x2. x3 is what? 0.7. No, s1 minus x3. That's the 0.5 minus s3, which is 0.7. Then s1 minus s4, which is 0.8. 0.5 minus 0.8. And the last one, s1 minus s5, which is 0.5 minus 1. So if you do this, that will be minus 0.45. Let me write it here so there will be space. So then, so I want to write it here. That will be minus the f of 0.9 now. To be the first one we are talking about, we are solving this one first. We'll get answer for this. We'll record it somewhere. That's minus 0.459 times 0.9 minus this, that's 0.3, times 0.9 minus this, 0.9 minus 0.7, that's 0.2, times 0.9 minus 0.8, that's 0.1, times 0.9 minus 1, that's minus 0.1, a negative. Minus, so that minus will turn this to plus automatically, so this one will be 0.1 also. I hope you understand that there's a negative here and there's negative here, turn to plus, divided by 0.5 minus 0.6, that's minus 0.1, times 0.5 minus 0.7, that's minus 0.2. So those two will be positive, times 0.5 minus 0.8, that's minus 0.3. We have negative again, times 0.5 minus 1, that's a negative, minus 0.5. So we solve this, 0.2 cancel 0.2. This negative all turn to plus because this and this will turn to plus. this antithesis also turns to plus. And 0.2 cancels 0.2, 0.1 cancels 0.1, 0.3 cancels 0.3. Then you have with 0. This times 0.1 divided by 0.5, that's 0.495 divided by 5. And if you calculate that, you should have, okay, let me see what that will give us. That's 0.459 times 0.1 divided by 0.5. That's 0.0098. That's 0. That's 0.000918, like this. So that's the first aspect. That's what this one gave us, the first aspect. We'll do the same thing for the second aspect. Let's take this one off. Just know that value, 0.0918. Now the second value, I'll not waste time on it. There's a reason why. The second aspect of the equation, we have the second aspect, we have f of x2. And what's f of x2 is 0. So 0 times anything will be 0. So everything here turns to 0 because f of x2 is 0. So no matter what you get here, times 0 will still give us 0. So there's no need wasting time writing everything. So f of x2 is 0 from here. F of x2. F of x2 is 0. So if you multiply with 0 to be 0, we don't need to waste time on that. So move to the third one, f of s3. F of s3 is 0.459. That will be 0.459 times x minus x1. What's our x? 0.9. 0.9 minus x1. What's our x1? Our x1 should be 0.5. 0.5. As we have it, x1 is 0.5 minus 0.5. Then x again, 0.9 minus x2. What's our x2? That's 0.6. And s again, 0.9 minus x4. What's our x4? 0.8. S again, what's our x? 0.9 minus x5, which is 1. Then divided by, what do we have here? x3. We're using x3. x3 is 0.7 minus 0.5. x1 is 0.5. x3 again, which is 0.7 minus s2 is 0.6. s3 again is 0.7 minus s4 is 0.8. Then s3 is 0.7 minus s5, which is 1. So let's calculate this. That will be 0.459 times 0.9 minus 0.5, that's 0.4, times 0.9 minus 0.6, that's 0.3, times 0.9 minus 0.8, that's 0.1, times 0.9 minus 1, that's minus 0.1, so we have a negative up there, divided by 0.5 minus 0.7, that's 0.2, times 0.7 minus 0.6, that's 0.1, times 0.7 minus 0.8, that's minus 0.1, so that negative cancel out, times 0.7 minus 1, that's minus 0.3, so the answer will be negative. This negative 0.1 cancel this negative 0.1. 0.1 here cancel this 0.1. 0.3 cancel this 0.3. So I left with 0.459 times 0.4 divided by 0.2. Then don't forget this negative. 0.459 times 0.4 divided by 0.2. That's negative 0.918. So the first one we got was 0.0918, but this one is negative 0.918. So let's go for the fourth one. I'm taking each of them one after the other, that's why. Because there's no space to write everything. So I'm moving to x. We are trying to solve this now for this. F of x for what's f of 0.849? 0.849 times x minus x1. x1 is 0.5 and x is 0.9. 0.9 minus x1 is 0.5. Close bracket, then open bracket, x minus x2. That's 0.9 minus x2. What's our x2? That's 0.6. Bracket, x minus x3. That's x is 0.9 that we're given. Minus x3. x3 is 0.7. Bracket, x minus x5. That's 0.9. X is 0.9. x5 is 1. Then divided by x4 that we are talking about minus x1. x4 is 0.8 and x1 is 0.5. Put them in brackets. Then x4 again minus x2. x4 minus x2, that's the 0.8 minus x2, which is 0.6. Brackets. x4 again, which is 0.8 minus x3. What's x3? 0.7. x4 again minus x5. x4 is 0.8 and x5 is 1. So we calculate this. That will be 0.849 times 0.5 minus this is 0.4 times 0.9 minus this is 0.3 times 0.9 minus this is 0.2 times 0.9 minus this is minus 1.0 minus 0.1, sorry, divided by 0.8 minus 0.5, that's 0.3. 0.8 minus 0.6, that's 0.2. 0.8 minus 0.7, that's 0.1. 0.8 minus 1, that's minus 0.2. So the minus will cancel out, sorry, times minus 0.2. So this minus will cancel out this minus. This will cancel out this. This will cancel out this. This will cancel out this. So I left with 0.849. 0.849 times 0.4 divided by 0.2. That's 1.698. So for x4, go to 1.698. So we've gotten four answers now. The first one is 0.0918. The second one is 0 because f of s2 was 0. The third one is 0.918. And the fourth one is 1.698. 1.698. So let's move on. We are going to the last one, which is f of x5. So f of this one, f of x5 is 1.2. So 1.2 times x minus x1. x1 is s is 0.9 and x1 is 0.5. Then x minus x2, which is 0.9 and x2 is 0.6. We check the values. X again minus 0.3. S is 0.9 and S3 is 0.7. Also 0.9, x is 0.9 minus s4, which is 0.8. 0.9 minus 0.8. So we can divide by x5 minus x1, which is 1. x5 is 1 minus x1, which is 0.5. s5 again minus x2. This is x2, s5 minus x2, which is also 1 minus 0.6 plus x2 is 0.6. Also x5 minus x3, which is 1 minus 0.7. Also x5 minus x4, which is 1 minus 0.8. 1 minus 0.8. So we do this, we're going to have 1.2 times 0.9 minus 0.5, that's 0.4, times 0.9 minus 0.6, that's 0.3, times 0.9 minus 0.7, that's 0.2, then times 0.9 minus 0.1, that's 0.1, divided by 1 minus 0.5 is what? 0.5. 1 minus 0.6, that's 0.4, times 1 minus 0.7, that's 0.3, and 1 minus 0.8, that's 0.2. So this cancel this, this cancel this, this cancel this. So you have 1.2 times 0.1 divided by 1.2 times 0.1 divided by 0.5. That's 0.2. So with all the values we've gotten, we can add it together to get our f of 0.9. So let's add all values. We've gotten value for each of the expression. So our f of 0.9 is now equals to the value we got for this first one when we solve, which is 0.0918 plus the value for this is 0, and the value for this for x3 when we do it for this x3 was minus 0.918. When we did it for x4 it was 1.698, and when we did for x5 it was the last one we did is 0.24. If we add all of this together, we should have 1.1118, which is what is expected, because when you interpolate it, you expect the value where we are interpolating is 0.9. So you expect it to be between 0.8 and 1.20, and this is between that, which is correct. Now we can go for degree 1 as they asked us to find it, degree 1, degree 2, and degree 3. One thing you should know that the higher the degree, the higher the accuracy. When you have higher degree, you have higher accuracy. Let me rub off all of this. For degree 1, for degree 1, that means it's just one equation. They are not having much equation. They are interpolating between two values. When you have degree 2, you are interpolating between three values. When you have degree 3, you are interpolating between four values. When you have degree 4, five values. This one was degree 4, that's why we are using five values to interpolate all these five values. So for degree 1 now, we need to interpolate between two values. Now you have to look at where are we interpolating 0.9. 0.9 for x is here. So that means we have to interpolate between these two values. As we are interpolating between the 0.65 now. 0.65 between 0.6 and 0.7. So that means we interpolate between these two values. So for this case, we are interpolating for 0.9. That means we are using these two values to interpolate. So we are having two values, which is x4 and then x5. We do the same thing the way you did it before. Now our f of x, now this thing, we are using x4 now. We want to use x4. That's f of x4. Now we are using the function x4. That will be times x minus, we use x4 again because we are using x4 minus x5. The rest of them, but just only one that remains. So minus x5, close bracket. There's no other thing to write. It should be x, this x minus x5. There's another thing, x minus x6. There's another one, x minus x7, but it's only just one. And we're not going to use this x4 because we're using x4 to interpolate. Divided by, now x4 that we're interpolating with, minus every other point, which is x5 that remain. So we are through with this to interpolate. We use also this to interpolate, plus f of x5 times, now will be x minus every other thing except from x5, and it's only x4 that remain. That's x4. There's another one to be bracket x minus the remaining one, divided by, we are interpolating with x5. That's x5 minus every other point that we have. There's only one point that we have, which is x4, x minus x4, and that's all. We don't have any other thing to do. So what's f of x4? F of x4 is 0.849. 0.849 times x minus 0 minus x5. What's x? 0.9 minus x5, which is 1, divided by x4. What's x4? 0.8 minus x5, which is 1, plus f of x5. What's f of x5? 1.2. 1.2 times x, which is 0.9, minus x4. What's x4? 0.8, divided by x5, which is 1, minus x4, which is 0.8. If we calculate this, we are going to have, we calculate this, we are going to have 0.849 times 0.9 minus 1, that's minus 0.1, divided by 0.8 minus 1, that's minus 0.2, plus 1.2 times 0.9 minus 1, that's 0.1. 1 minus 0.8, that's 0.2. If we do this, we going to have this cancel this, so it's positive. That's 0.8849 times 0.1 divided by 0.2. That's 0.4245. 0.4245 plus 1.2 times 0.1. 1.2 times 0.1 divided by 0.2. That's 0.6. Add these two together, that means your f of 0.9 for 1 degree is equals to plus 0.6 plus 0.4245. That's 1.4245. 0.0245. So that's for the first degree. We do the same thing for the second degree. When I talk about second degree, we are going to have three equations. We use three values. Oh, and three equations. So let's do for the third degree. For the third degree, we're going to use these three values because 0.9 is between those three values. So that will be, we have x3, x4, and then x5, those three values. So we start with f of x, the equation for interpolation is equals to, let's pick this first, fx3 times, so since we pick this, so we subtract x from every other two, the remaining two, that's x minus x4, and then x minus x5 divided by, now x3 against the remaining two, x3 minus x4, and then x3 minus x5 plus, now we've done for f of x3, let's do f of x4 plus f of x4 times, since we are using x4, so x will subtract 3 and 5, that's x minus x3, x minus x5 divided by x4 will subtract the remaining two, x4 minus x3, and then x4 minus x5. So we do for the last one, when we interpolate 4 too, we need to interpolate 5, that's f of x5 plus f of x5 times s to subtract the remaining two, 3 and 4, x minus x3, x minus x4 divided by x5 is subtract the remaining two, x5 minus x3, x5 minus x4. So we solve this. F of 0.9 now. What's f of x3? That's 0.459. 0.459 times, so x, which is x is 0.9 minus x4 is 0.8, bracket x is 0.9 minus x5, which is 1, divided by x3, which is 0.7 minus x4, which is 0.8, then x3, which is 0.7 minus x5, which is 1, then plus f of x4, that's 0.849, 0.849 times x minus x3, x is 0.9 minus x3, x is 0.7, then x minus x5, that's the 0.9, which is x, minus x5, which is 1, divided by s4 minus x3. What's s4? 0.8, 0.8 minus x3, which is 0.7, brackets x4 is still 0.8 minus x5, which is 1, plus f of x5, which is 1.2, times x minus x3, 0.9, x3 minus 0.7, then x minus s4, 0.9, s4 is 0.8, divided by x5, which is 1, minus s3, which is 0.7, s5 again, which is 1, minus x4, which is 0.8. So we calculate this, that's 0.459 times 0.9 minus 0.8, that's 0.1, times 0.9 minus 1, that's minus 0.1, divided by 0.7 minus this, that's minus 0.1, 0.7 minus 1, that's minus 0.3. So plus 0.849 times 0.9 minus 0.7, that's 0.2, times 0.9 minus 0 minus 1, that's minus 0.1, divided by 0.8 minus 0.7, that's 0.1, 0.8 minus 1, that's minus 0.2, plus 1.2 times 0.9 minus 0.7, that's 0.2, times 0.9 minus 0.8, that's 0.1, 1 minus 0.7, that's 0.3, 1 minus 0.8, that's 0.2. So we do that, this will cancel this minus will cancel this minus, and this will cancel this, and this will cancel this. Then this will cancel this, and this minus will cancel this minus, and left with one minus. That means this answer will be negative. We're going to have 0. Coming 0. 0.459 times 0.1 divided by 0.3. That's minus 0.153 plus this is just 0.849 plus 1.2 times 0.1.2 times 0.1 divided by 0.3, that's 0.4. And let's add everything together. 0.4 plus 0.849 plus minus 0.153, that's 1.096. So for degree 2, this is what we have for degree 2. So we do the same thing for degree 3. For degree 3, I'll just put the formula, then you put the values yourself to confirm the answer. The answer is actually, for degree 3, is 1.1145. Notice that the higher the degree, the higher the accuracy. The higher the degree, the higher the accuracy. So let's talk about degree 3. For degree 3, we're going to have 4x. For degree 3 now, We're going to start from here and stop here. 4 of them. So we have x2, x3, x4, and then x5. Then you write your equation the way we have been writing it. F of x now for the interpolation. Let me just write the formula, then you complete it yourself. That will be, let's take s2 first. F of x2 times x minus the other one, s3 to s5, s3, x minus x4, and then x minus x5 divided by, we take the interpolation with the other one, that will be x2 minus x3, x2 minus x4, x2 minus x5. So that's for the first one. Do the same thing for the second one, which is f of x3 plus f of x3 times s to take away that value except from x3, x minus x2, x minus x4, and x minus x5 divided by x3 will take away that value, x3 minus x2, x3 minus x4, and then x3 minus x5, then plus x4 now, f of x4, f of x4 times x minus the other one, x2, x minus x3, x minus x5, then divided by x minus x5, then the other one, that will be x4 minus x2, then x4 minus x3, then x4 minus x5. So you have to just put all this value yourself, plus f of x5. Now you'll have been seeing the correlation among all of them, times x to subtract every other value apart from x5. That's x minus x2, x minus x3, and x minus x4 divided by x4, no, x5, sorry, x5, we're using x5 now, minus x2, x5 minus x3, and then x5 minus x4. So you solve this yourself, you interpolate it, and you should get your f of 0.9 to be equals to 1.1145, which is this. So notice that the higher the degree, the higher the accuracy. When you increase the degree, you have more accuracy. When we use the first equivalent, the first degree, we had 1.2045. When we use the second degree, we have 1.909 or 1.096. When we use the third degree, we have 1.1145. When we interpolate it normally, we add 1.1118. So this is what I'm going. So that's the end for this aspect of the question. So stop here for now.